All right, so we are just going to start our next unit, which is looking at population regulation. So the core of this is really going to be understanding how do we understand population growth, okay, and how can we sort of measure and track it. And so we're going to be looking at a lot of different graphs. We're going to be doing a little bit of math, but it's going to look a lot math heavier than it actually is. So we'll walk through some of this and look at it. So the idea here is looking at population reproduction and how that affects the growth of population from one year to the next in a given area. So we're going to be looking at several different features that affect population growth rates, some of them being more obvious than others, certainly birth and death. But we'll also look at things like fecundity and survivorship and how that differs from survival. And then we'll look at several different ways that we can track population growth. So the one way that we tend to do it are things called life tables, and that'll be the one time that we actually do real math. So we can track each age group and how they contribute to the overall growth of a population. And then we'll look at a few different variables, which we aren't going to actually use the math for. But we'll look at how these variables are used differently. So basically, organisms that breed yearly versus organisms that breed continuously, and how that affects the way their population grows. Okay. And then at the end, we're going to look at population regulation. So what kind of factors affect the fact that, despite the fact it will look originally like populations can grow infinitely, right? There is some sort of control and cap on the way populations grow, and how we calculate that, and how some populations, like ours, inadvertently sort of ignore it altogether. All right, let's rock forward. All right, so ultimately, as I mentioned, sort of the end goal here is we want to track how populations grow. This is interesting to us, right? And this is another big feature that we care about, particularly when we think about things like conservation and policy, right? But we also understand that there are lots of factors that affect, right, what slows their growth and what caps their growth in a given area. Okay? Some of that is global, some of that is ecosystem-based, and some of that's sort of all on us. So it's really understanding that from the population's perspective, and as we'll find, particularly when we look at the life tables, some of that is different sensitivities for each age group. And we sort of understand that even from a human perspective, right? Different age classes are more sensitive to death than other age groups, right? They're more resilient. Okay. So a lot of this unit is going to be looking at what can we do as budding ecologists to understand these factors. Okay? And once you understand them, you can understand how you can better promote protection, conservation, all of that sort of good business. Okay, so if we think about the example I have up here, the sea turtle, okay, a lot of sea turtle conservation is focused on the easiest one, which is baby sea turtles, right? Save their eggs when they're buried in the sand, okay? Save them because they are not super great anymore, rushing out to sea. And this is good, okay? But realistically, the most important, as you find if you look at a life table turtle, the most important stage of a life turtle, a turtle's life, went like all Yoda on you guys there for a second, is actually their adult phase, right? Because that's the phase in which they will actually breed, okay, and be actually able to make baby sea turtles. Now, the reason most sea turtle conservation isn't focused on that is because there's a huge gap in understanding on what happens when baby sea turtles leave and come back, right? We have no idea in a lot of cases, what happens in between there. So it's extraordinarily difficult to do anything about it in their most sensitive life stages, right? Somewhere in those first 50 years when they're growing up to actually get to the breeding stage, poof, no idea what's going on. So despite the fact we know that's their most sensitive stage, we need adult sea turtles getting their freak on and burying their eggs, okay, so we can have more baby sea turtles. It's super hard to do anything about that. Okay, so then we focus on the less sensitive life stage. Yes, they die more, but there's hundreds of thousands of them. So understanding these influences and enacting policy also sometimes mismatch. Okay. With me so far? Right, those are our goals. All right, so things that we're sort of accustomed to dealing with, intuitive ideas. Okay, so birth and death rate. Okay, we know, first off, that these are important, okay, and they vary greatly. Okay, now, sometimes age matters. Okay, so we know, for example, like in mammals, age is very important when you're thinking about both survivorship and reproduction. Okay, so how old you are likely plays a role in how likely you are to survive. And also, how old you are, how many years you've been around, is going to dictate whether or not you have reached reproductive potential. Okay, within some kind of confidence interval. Okay, but that's playing a role. In other species, age does not matter. Okay, so with like plants and fishes, okay, the actual growth you have achieved is what matters here. Now, certainly time with this, but size is what matters. Okay, so there's a minimum threshold of size that you have to reach to be able to be more likely to survive and reproduce, right? So if I'm a fish and I'm a lady fish, to start reproducing eggs, right, if I'm a little guppy, for example, I just need to be an inch. Okay, I can be 3 years old, and if life stinks super bad and I never reach that size, I just never have babies, right? I never get big enough to do it. Okay, that's how it happens with humans. Okay, girls hit 15, you get a period. That sucks. It doesn't matter how good or bad your life is, okay, unless you're super sick, you hit reproductive age no matter what. So this is different for different organisms. Plants are often the same way. Okay, you can be around for 50 years, but if the soil stinks, you never produce pollen or a flower because you're too small and scraggly. Okay, there's no 50-year-old human that at some point, unless they're sick, have not had reproductive potential. Okay, whether you've actually reproduced, a whole different issue. Okay, so this is what we're talking about. We're talking about birth, death rates, and then ultimately the question of reproduction, which is fecundity. Okay, feel okay so far? It's pretty intuitive. Okay, so let's talk about what we call survivorship curves. Okay, and we're not going to dive into life tables today, but we can talk about the pieces that go into them. All right, so survivorship curves, okay, basically deal with how many individuals that were born are literally going to survive to a past breeding age, or at least full on a whole year of breeding age, because there's a handful of organisms that only breed once, right? Okay, so fulfilling a full life cycle. Okay, so we have 3 different pathways of life, if you will, that generally organisms can classify themselves into. Okay, which basically go into how many offspring kick the bucket before they reproduce.